So what we would like to do is look at, in a little more detail, what climate parameter is driving the interannual peak summer NDVI. And it turns out that is pretty difficult because although we have a really strong correlation between climate stations, in this example, Fairbanks and Big Delta are climate stations on the Nenana River floodplain, and they're about 100 miles away from each other. If we look at precipitation, so total July and June precipitation between these two similar climate stations on the Nenana River floodplain, there's a lot of variation. So there's a lot of local variation in terms of precipitation among climate stations. So if we try to use a gridded precipitation product, it really depends on which gridded precipitation product we use. So here's an example from McAfee et al., where they looked at 2008 precipitation compared to 1950 precipitation using three gridded precipitation products. And they tell three different stories. So this product is telling a story of drought, significant drought in northeastern Alaska. And this product is telling a different story of significant drought in southwest Alaska. And then this product basically is telling the story of drought throughout the entire western part of Alaska. So one approach could be we'll use climate stations and we'll buffer 10 kilometers around each climate station and then use the precipitation and temperature that was measured at each climate station. So here we have 26 climate stations distributed between the Alaska Range and the Brooks Range in the Boreal region of Alaska. So what is the response of peak summer NDVI within these climate station buffers? So surprisingly, we have a similar response following the drought of 2004. And at all these climate stations, they actually had peak summer NDVI above the long-term average, which would be at 0 during this drought year. So there's a lag effect. So 2003 was a wet summer, so most of these climate stations had a peak NDVI in 2004. Despite being a drought year, their peak NDVI was actually higher than normal. And then they consistently declined in NDVI the following summer after drought, and then most of them continued to decline in NDVI 2 summers after drought. And then finally we have a recovery 3 summers following drought. So drought affects peak summer NDVI in a big way, and that effect can be lagged by up to 2 summers. Well, what about early springs versus late springs? So in theory, if we have an early spring, we would have a decline in soil moisture, and then the summer drought would be even more of effect. Well, it turns out if we look at the date of ice out at Nenana or the date of bud bursts in Fairbanks and the peak summer NDVI, there was no relationship. So here we have the date of observed bud bursts in the spring and then what the mean NDVI was at Fairbanks, and here we have the date of ice out on the Nenana River and then the peak NDVI at Nenana, and there was no relationship between these late spring versus early spring indicators.